Why does water form on the surface of a cold water bottle or glass with cold water? Water or water droplets form on the surface of the cold water bottle or glass with cold water due to a process called condensation. Condensation occurs when warm, moist air comes into contact with a colder surface, which is yung surface ng bottle at glass, causing the moisture in the air to condense from gaseous state to liquid state. In this case, the surface of both containers are colder than the surrounding air. So when warm, humid air in the room comes into contact with the cold surface of the containers, yung temperature ng air ay nagde-decrease. As a result, there is too much moisture so hindi na kayang i-hold ng air. Kaya yung excess moisture ay nagko-condense sa malamig na surface ng container, forming the water droplets. So, in this case, we can conclude that the moisture in the air changes from a vapor to a liquid state as a result of temperature differences between the air and the surface. That's all po, ma'am.
Okay, so good morning po. Now, let me discuss to you how does a refrigerator work. So, we all know na ang refrigerator ay isa sa mga functional appliances that we have in our home. And yung fundamental reason bakit natin siya ginagamit or why we have it in our home is para mag-preserve ng food natin. So, paano nga ba nape-preserve ng refrigerator yung mga foods and drinks natin. So of course, by the or through the cold temperature. Yung cold temperature na yun, it helps our food to stay fresh longer. And also yung cold temperature ay pinapabagal niya yung activities ng bacteria na kinocontain ng foods. So it will take longer for them to spoil the food. But behind that ay paano nga ba nagwo-work ang refrigerator? Paano niya nagagampanan yun? So, ang refrigerator kasi isa siyang closed loop system na it is consist of major components such as the compressor, yung condenser, yung expansion device, and also the evaporator. And I know we are all familiar with those components since we have already discussed those components. So first, let's start with the compressor. Okay. Ma'am, pwede po bang mag-drawing po dito sa slide? So, erase ko na lang po later.
Okay. Sige.
Okay. So, first, let's start with the compressor. So, andito yung compressor sa baba. Example. And then, dyan mag-start yung process natin. So, yung compression ng refrigerant ay dyan mag-o-occur. And once the refrigerant is compressed, it will heat up. So, tataas din yung pressure natin. Yung high pressure and high temperature refrigerant ay mag-enter dito sa condenser. So, ito, ayan, yung ganyang itsura sa likod ng refrigerator natin. So, ayan yun. Ayan yung condenser. And then, once nag-enter dyan yung ating liquid, yung ating refrigerant ay, ayan, yung coil together or along with the relatively cool air dito sa labas ng ating refrigerator, it will convert the refrigerant into liquid state. So, yung heat ng ating refrigerant ay marirelease siya dito sa ating atmosphere. Ayan. So, kaya kung ma-observe natin or mapapansin natin, medyo warm yung surrounding dun sa likod na part ng ating refrigerator. And, ayan. So, yung liquid, yung na-convert natin na liquid na refrigerant ay ta-travel na siya papunta sa ating expansion. Ayan. Sorry po. Papunta sa ating expansion device. So, dyan may expand yung refrigerant natin. And then, when expansion occurs, magde-decrease yung mga molecules. At kapag nag-decrease yung molecules natin, ay magkokos din siya ng pagbagsak ng temperature. So, yung low pressure, low temperature refrigerant natin ay it will make its way papunta sa ating evaporator. Ayan. Ayan. And, diba? Ayan. So, yung refrigerant, magpapass through siya dyan sa ating evaporator coils. And then, i-absorb niya lahat ng heat na present doon sa loob ng ating refrigerant compartment o yung refrigerator compartment. So, once na inabsorb niya yung heat, it will leave the refrigerator compartment cold. So, now it is ready para to make our food cold and fresh. So, dito na mag-o-occur yung main cooling effect at saka yung refrigeration effect niya. And also, yung ating refrigerator kasi, meron siyang mga series of vents para mag-pass through or lumagpas yung cool air between the refrigerator compartment and dun sa freezer. So, ayun, kaya malamig din. And then, ayun, yung ating low pressure vapor ay will travel back dito sa ating compressor. And then, the cycle will just continue. And as the cycle continue po ay, ayun, it will help the refrigerator compartment to maintain its temperature po. So that's how a refrigerator work. Next na po.
So, how does an air conditioner work? So, balang alam po natin sa air conditioner nga po ay nagpapalamig ng ating mga room. And bali ang principle po ng ating air conditioner ay nag-operate po based on thermodynamic principle of heat transfer. So, may tawag din po dito na sa ability po na ito na tawag po ay refrigerants na nag-absorb po at nagre-release ng heat during the phase changes po between liquid and gas states. So, halos same lang din po sa refrigerator. Meron po tayong key components po ng air conditioning system. So, we have po the evaporator na nag-drum po ng warm air and tsaka po nag-cool. Tapos next po ay compressor na ito po ay pump na nag-i-increase po ng pressure and temperature of the refrigerant. So next po is condenser, which is po heat exchanger din po na nag-extract po ng heat from indoors na nag-release po sa surrounding environment. And we have the expansion valve na yun nga po, nag-regulates po ng flow and pressure ng refrigerant. At saka po, yung pong nadagdag ay fan din po na nagbo-blow po ng air over the evaporator po and condenser to facilitate the heat transfer po. So, ang operation cycle po ng air conditioner ay nagsisimula nga po sa warm air na inintake po ang warm air na galing po sa room. Next po ay yung pong sa evaporator na dito po nagpapas yung air over the cold evaporator coils where the refrigerant absorbs ang heat po from the air, causing it to cool down and condense into water droplets. Next po is the refrigerant cycle. So, meron po tayong compression, nga po, tas condensation, at saka pa expansion. So, compression po na nangyari yung low pressure at yung cold refrigerant po is drawn into the compressor, which increases its nga po, pressure and temperature. Then, yung condensation din po na yung hot po and high pressure refrigerant na nagta-travels po to the condenser and nire-release po yung heat to the surrounding air and nagka-condense naman po back into a liquid. Then, next po ay yung expansion na yung cold liquid naman po ng refrigerant ay nagpapass through po sa expansion valve, which reduces naman po the pressure and temperature. And lastly po ay yung cold air distribution na yun nga po, nilalabas na po nung yung cold refrigerant sa ating room po. Tapos po ay yun nga po, yung cold and natin, sa po natin tinatawag na the humidified air is then, yun nga po, circulated po by the fan. So, ang conclusion po ay ang system po ng air conditioner ay, yun nga po, nagpo-provide po ng comfortable na thermal environment sa isang indoor space or to the outdoors using a refrigerant cycle. So, this process po involves heat absorption at the evaporator, thus compression and heat rejection at the condenser, and pressure reduction before returning to the evaporator. Yun lang po.
Good morning po. Now po I will discuss how refrigeration and air conditioning works. First po is how air condition works. As we all know po, refrigeration is designed to cool an immediate area. And nagagawa po ito ng refrigerators by using pipes filled with coolant. Na yung coolant po natin ay usually F-gases or yung fluorinated greenhouse gases, which forces from a liquid into gas to create the cooling effect inside the fridge. Then yung compressor po ang mag-i-increase ng pressure and temperature to turn F-gases back into liquid para po maulit yung process. But not before putting the coolant through a condenser. Then yung coolant po will continuously flow throughout the maze of tubing para ma-remove yung heat and to keep temperature low in a confined space. Next po is how air conditioning works. Air conditioning uses the same principle of using a coolant already built into the system. But dito po, sa air conditioning, the warm air inside the room is drawn in and it is part of the heating process. Air conditioner will use lots of ductworks and fans to push the hot or cold air around the building para po ma-achieve yung lamig sa kung gaano kalaki yung isang room. And unlike po sa refrigeration, air conditioning removes heat and moisture to create a more comfortable working space when cooling. So, ayun po yung kung paano gumagana yung refrigeration and air conditions. May similarities po sila but the key differences are refrigeration keeps the cold air close while air conditioning pushes it away. Next po is refrigeration uses coolant alone while air conditioning uses coolant plus the air from the outside. And lastly po, refrigeration deals with cooling and freezing while air conditioning deals with cooling and dehumidifying the air.
So, a brief history of refrigeration po. The methods of production of cold by mechanical processes are quite recent. Long back in 1748, William Cullen of Glasgow University produced refrigeration by creating partial vacuum over ethyl ether. But he could not implement his experience in practice. The first development took place in 1834 when Perkins proposed a hand-operated compressor machine working on ether. Then in 1851 came Gore's air refrigeration machine, and in 1856 Linde developed a machine working on ammonia. So sila po yung mga tao na mayroong malaking contribution po sa development ng refrigeration technology. And these innovations po laid the groundwork for modern refrigeration technology. Yun lamang po. Next po.
Refrigeration is the process of moving heat from one location to another by the use of refrigerant in a closed cycle. Sinasabi po rito na refrigeration involves nag-i-involve po ng pagpapasa ng init o heat na galing sa mas mababang temperature environment papuntang high temp environment gamit po ang refrigerant. For example po, refrigerator. Inaabsorb po ng refrigerant yung init na galing sa loob ng refrigerator at dinadala ito papuntang condenser kung saan naman po dun niya i-release yung heat kaya po nananatiling malamig yung mga refrigerator natin. Refrigeration is simply cooling by removing heat. Gaya nga po ng sabi ko, yung refrigerator ay tinatanggal niya yung heat para manatiling malamig po yung loob ng ating mga refrigerator. Application includes air conditioning, commercial refrigeration, and industrial refrigeration.
So sa heat naman po, heat is a form of energy which can exist on its own and can be moved from one place to another. Heat is not a matter that can be measured by weight or volume. Heat can also come from other forms or of energy. For example, motors that use electricity will generate heat. Heat will not flow without a temperature difference. The heat will only transfer from a high energy source, high temperature, to a low energy source, or cooler temperature. The bigger the temperature difference, the more heat is transferred. So unlike po dun sa refrigeration natin na inaalis na nagre-remove po ng heat in a closed cycle, dito naman po sa heat, ang basic knowledge po natin dito is, example po natin is yung, ano po, yung lagi sinasabi po natin mga nakakatanda with regards to the air conditioning po. Pag po nakabukas yung pinto na sa isang room, tapos sinabi po ng matanda is, lumalabas yung lamig. But that was not correct po. Based po dun sa ating explanation po, heat is, ano po, pumupunta siya sa mga malalamig na temperature which is, yung maling concept po nun is pumapasok po yung init sa isang closed room, kaya po, no, kaya po nafe-feel natin na nawawala yung lamig. Pumapasok po yung init sa room with air conditioning and that's the heat, ano po, kumaga po yung flow po nating heat na nagmo-move from high temperature to low energy source. Yun lang po yung basic knowledge po with regards sa heat.
This diagram po shows the refrigeration process, and to elaborate more its components, sa evaporator nga po kung saan ang refrigerants ay maabot sa state ng gas at sabay po nito yung pag-absorb ng init mula sa surroundings, kaya po yung nagyayelo po ito. And sa compressor naman po, yun po yung next destination ng mga ice refrigerants na ito at nag-increase po dito yung pressure at temperature para maging gas state ulit. And yung pong gas na ito ay nag-circulate sa condenser kung saan ito ay pinapalamig hanggang maging liquid state ulit. Then yung liquid naman pong ito ay dumadaan sa metering device na siya naman pong nagko-control sa dami ng refrigerants na nag-enter sa evaporator. At yung process pong iyon ay patuloy at paulit-ulit lamang. And then we therefore conclude po na by continuously circulating refrigerants through these components, a refrigeration system can maintain a consistent temperature in a space or keep substances cool, such as in refrigerators, air conditioners, and other cooling systems po.
Okay, Janela, can you please read the slide?
A typical refrigerant R134A has a boiling point of negative 15.34 degrees Fahrenheit. Since the hot summer air is above the boiling point of the refrigerant would boil at that temperature. The most commonly used refrigeration system is called the direct expansion vapor compression system.
And also, ito nasa in-call messages.
Ayun. So, for page 9, we need to know first what is refrigerant. Ito yung working liquid na present sa loob ng ating refrigeration system. Ito ay may mababang boiling point lang na kung saan ay napaka-importante para sa pag-change ng phase nito sa loob ng cycle. Example na lang ay yung sa evaporator na kung ginagawang vapor ang mixture of liquid and vapor na pinapasok dito gamit lang ang temperature ng surroundings. Then yung refrigerant R134A naman ay yung kadalasang ginagamit sa cycle na to.
Okay, next. So, siguro naman you have the idea kung bakit yung mga refrigerant natin, iyon yung ginagamit. So, at least in your design project, alam nyo na yung mga dapat i-consider. And the idea kung bakit ito yung mga refrigerant like ammonia and this R134A. So, meron silang mababang freezing point and then mababa din yung compared with the temperature of the water, mababa din yung kanyang boiling point. Mas malaki yung ibinaba. Okay, next na tayo.
Introduction to refrigeration systems. 1. Terminologies. 2. System and practices. 3. Component and equipment. 4. Food cooling and storage. 5. Refrigerated transport. 6. Food, beverage, and floral applications. 7. Industrial applications. 8. Low temperature applications. And 9. Code and standards. Next po. 2. System and practices. So 2.1 hollow carbon refrigeration systems. It refers to cooling systems that utilize hollow carbon compounds such as chlorofluorocarbons, hydro. So next po is ammonia refrigeration systems. It is utilize ammonia or NH3 as the refrigerant. Ammonia is a natural, efficient, and environmentally friendly refrigerant with zero ozone depletion potential and a very low global warming potential. Because it is a favorable environmental profile, ammonia is widely used in large-scale industrial refrigeration applications, such as cold storage warehouse, food processing facilities, ice rinks, and chemical plants. Next po is carbon dioxide refrigeration system. Carbon dioxide refrigeration systems, also known as transcritical CO2 systems, use carbon dioxide as refrigerant. These systems have gained popularity as environmentally friendly alternatives to traditional synthetic refrigeration due to CO2's low global warming potential. Next po is the liquid overfeed systems. Liquid overfeed systems are a type of refrigeration systems where the refrigerant is continuously circulated through the evaporator coil in excess of the refrigeration load. Next po is component balancing in the refrigeration system. Component balancing in refrigeration systems refers to the process of ensuring that all components within the system, such as compressor, condenser, evaporator, expansion devices, and piping, are properly sized and optimized to work together efficiently. Next is refrigerant system chemistry. Refrigerant system chemistry encompasses the chemical properties and interactions of the refrigerant used in a refrigeration system. Next is control of moisture and other contaminants in refrigerant systems. Controlling moisture, and other contaminants in refrigerant systems is crucial for maintaining system performance, reliability, and longevity. Moisture, air, acids, and other contaminants can degrade system components, reduce efficiency, and lead to system malfunctions. Here are some. The use of dry refrigerants. Start by using dry, clean refrigerants. Contaminants such as moisture and acids can be present in refrigerants. Next po is equipment and system dehydrating, charging, and testing. By following proper dehydrating, charging, and testing procedures, refrigeration system installers and technicians can ensure the system are free of moisture, properly charged with refrigerant, and operating safely and efficiently. Regular maintenance and testings are essential to detect and address any issues properly, preventing downtime and costly repairs. The last is refrigerant containment, recovery, recycling, and reclamation. Refrigerant containment, recovery, and reclamation are essential processes in the management of refrigerants to minimize environmental impact, ensure compliance with regulation, and promote sustainability. Next po.
Sino dito? Parang yung naka-assign dito ay on din. Ang sabi ko, babasahin lang yung content ng 2, tapos ito yung explain niya mismo.
Akin din po, ma'am. 2.1 Halocarbon refrigerants are classified into 4 groups. 1. Chlorofluorocarbons, CFCs, which contain carbon, chlorine, and fluorine. Number 2. Hydrochlorofluorocarbons, which consist of carbon, hydrogen, chlorine, and fluorine. Hydrofluorocarbons, HFCs, which contain carbon, hydrogen, and fluorine. Hydrofluorolefins, which are HFC refrigerants derived from an alkene.
Sino sunod sa'yo, Ian?
Ako po, ma'am. Good morning po.
Ayan. Sige.
For hollow carbon refrigeration systems, the desired characteristics of a hollow carbon refrigeration system may include year-round operation regardless of outdoor ambient conditions, possible wide load variations, 0 to 100% capacity during short periods without serious disruption of the required temperature levels, frost control for continuous performance applications, oil management for different refrigerants under varying load and temperature conditions, a wide choice of heat exchange methods, including dry expansion, liquid overfeed, or flooded feed of the refrigerants, and use of secondary coolants such as salt, brine, alcohol, glycol, and carbon dioxide. System efficiency, maintainability, and operating simplicity. And last one is operating pressures and pressure ratios that might require multi-staging cascading, and etc. So for year-round operation, sinasabi lang dito that a hollow carbon refrigeration system must have a year-round operation regardless of outdoor ambient conditions. Uh, this means that the system of hollow carbon must keep things cold regardless of external factors, which is crucial for industries with strict temperature control requirements. And another key aspect is the ability to accommodate wide load variation, which is ranging from 0 to 100% capacity without significant disruption to the required temperature levels. So, this means that the system is ideal when it comes to handling sudden changes in demand. So, whether maliit yung load or malaki yung load, the system must adjust from minimal to maximum capacity during short periods without compromising temperature stability. So the next one for frost control, for applications requiring continuous performance, hollow carbon refrigeration systems incorporate must incorporate robust frost control mechanisms. So these mechanisms prevent the buildup of frost, which ensures uninterrupted operation and preserving product integrity. The next one is that ensuring proper oil management is crucial for maintaining system integrity and efficiency, as hollow carbon refrigeration systems are designed to manage different refrigerants under varying load and temperature conditions, ensuring smooth operation and prolonging component lifespan. The next one is that hollow carbon refrigeration systems offer a wide array of heat exchange methods, including dry expansion, liquid overfeed, and flooded feed of refrigerants. So additionally, they can utilize secondary coolants, which is, ang sabi dito, mga salt, per-alcohol, glycol, and carbon dioxide, which enhance adaptability to diverse operational needs. The next one is that efficiency, maintainability, and operating simplicity are fundamental principles within hollow carbon refrigeration systems. So these systems are engineered to deliver optimal performance while minimizing energy consumption and operational cost, hence maximizing productivity and reliability. And then the last one is that hollow carbon refrigeration systems must be capable of managing varying operating pressures and pressure ratios. So they may employ multi-staging and cascading configurations to ensure optimal performance across a range of operating conditions to further enhance systems flexibility and effectiveness. That's it po.
Good morning po. Rinig po, ma'am. Next po ay ammonia refrigeration system. Custom engineered ammonia or R-717 refrigeration systems often have design conditions that span a wide range of evaporating and condensing temperature. Ang ibig pong sabihin nito ay yung custom engineered ammonia refrigeration system ay may iba-iba po siyang range ng temperature, yung mga design component niya, kung saan magaganap yung evaporation at condensation. Halimbawa po nito ay sa food freezing plant operating na may range po ng 10 to negative 45 degrees Celsius. Pangalawa po ay candy storage requiring 15 degrees Celsius decibels with precise humidity control. Pangatlo po ay a beef chill room at negative 2 to negative 1 degrees Celsius with high humidity. Pangapat po ay a distribution warehouse requiring multiple temperatures for storing ice cream, frozen food, meat, and produce end products. And lastly, a chemical process requiring multiple temperatures ranging from 15 to negative 50 degrees Celsius. Ammonia is the refrigerant of choice for many industrial refrigeration system. Kaya po ammonia yung madalas pong ginagamit ng mga industrial refrigeration system ay dahil yung ammonia po ay mas mataas o mas better po yung heat transfer properties niya kumpara po sa ibang mga chemical refrigerant. Dahil po dito ay mas mababa po yung magiging cost ng fabrication po. Yun lang po.
So for this slide naman po is ang focus po nung slide na to is it discusses about carbon dioxide referred to as R744 na is one of the naturally occurring compounds collectively known as natural refrigerant. So we all know that CO2 ay major contributor po siya ng global warming or climate change, specifically being a hydrofluorocarbons and chlorofluorocarbons. So negative effect po siya pero by use of technology po and industry also uses it in various industrial applications such as refrigerant. So by utilizing CO2 as a refrigerant, industries can potentially reduce their carbon footprint and contribute to climate change mitigation efforts. Since yung CO2 po is wala po siyang negative compounds such as mutagenic and carcinogenic na may harmful effect po sa environment. So ayun lang po yung focus ng slide na to. Thank you po.
Next naman po ay yung parang continuation lang din po to ng carbon dioxide refrigeration systems yung kanina. Nung early days po, since kokonti na lang yung suitable na chemical compounds na pwedeng magamit as refrigerants and limited na rin po yung available na equipment para sa refrigeration, ay naging active na refrigerant ang carbon dioxide dahil sa widespread availability nito. And sabi nga po dito, the use of carbon dioxide refrigeration systems became established in the 1890s, and carbon dioxide became the refrigerant of choice for freezing and transporting perishable food products around the world. And kadalasan po, yung mga meat and other food products na galing pa sa ibang bansa ay siniship via refrigerated vessels for distribution and consumption. Ino-operate po ang system by compressing carbon dioxide gas para mag-create ng cooling effect na magsisirculate sa mga insulated chambers or containers para mag-maintain ng low temperatures necessary for preserving food freshness. And despite having traveled several weeks sa pag-ship, yung mga nare-receive po ng consumer ay kadalasang sinasabi na halos same lang yung condition ng frozen meat na natatanggap nila doon sa mga fresh meat products sa market. Kaya nung 1900s na po, over 300 refrigerated ships ang nagde-deliver ng meat products sa iba't ibang lugar. And dito na rin po nagiging ng dominance ang carbon dioxide as a refrigerant in marine applications ranging from coolers and freezers. Kaya masasabi din po natin na during the late 19th and early 20th centuries, carbon dioxide refrigeration systems played a crucial role in the transportation of perishable goods, and sa pag-invent ng mga refrigerated vessels, mas napapadali na po yung pagtatransport sa malalayong lugar without significant spoilage. And this also led to the expansion of global trade networks sa pag-export ng mga products sa markets. In the 1890s, CO2 was widely adopted as a refrigerant due to its effectiveness and safety compared po sa ibang refrigerants available at the time. Yun lang po.
Liquid overfeed systems. Overfeed systems force liquid in excess of the amount evaporated either mechanically or by gas pressure through organized flow evaporators. Separate it from the vapor and return it to the evaporators. Mechanically pumped systems usually pump from a vessel at the connected suction pressure that is low. It pumps low temperature liquid. Gas operated systems can be configured to deliver either low temperature liquid directly like the mechanically pumped system or subcooled from a controlled pressure receiver at an intermediate pressure. With the latter, the accumulated overfed liquid is transferred from the low pressure receiver back to the controlled pressure receiver. In simple terms po, liquid overfeed systems, yun pong, sa liquid overfeed systems po, yun pong excess na refrigerant na hindi nag-evaporate sa evaporator, yun po ay pupunta sa receiver tapos mariredirect po ulit siya sa evaporators. Ang liquid overfeed systems po ay widely used in large-scale industrial refrigeration systems dahil po sa kanyang dagdag efficiency. Tumataas po yung efficiency dahil nga po yung excess liquid na mariredirect po sa evaporator ay ready na po, parang malapit na po siyang mag-evaporate. Kaya po, mas marami, dahil nga po may extrang liquid na mag-evaporate sa evaporator, mas marami po siyang na-absorb na heat. And tumataas po yung heat sa evaporator, tapos yun po namang sa compressor, nababawasan po yung kailangan niyang i-compress na liquid, kaya po bumaba yung temperature. Sa pagbaba po ng temperature sa nilalabas ng compressor, tapos sa pagtaas po ng temperature sa evaporator, tumataas po yung coefficient of performance o yung COP. Kaso po ang disadvantage naman po nito, magkakaroon po ng extrang components like receivers o kaya pump para ma-pump ulit sa evaporator, kaya po tumataas po yung initial cost. Yun lang po. Next.
Component of balancing in refrigeration system. A refrigerant is a fluid used for heat transfer in a refrigeration system. The fluid absorbs heat at low temperature and pressure and transfer heat at a higher temperature and pressure. Heat transfer can involve either a complete or partial change of state in the case of primary refrigerant. So bali po yung atin pong refrigerant is may malaking role sa ating refrigeration system. Bali ang nangyayaring proseso sa ating refrigeration system ay ina-absorb ng ating refrigerant ang heat at low pressure and temperature and release it in a high temperature and pressure. Energy is a function of the heat transfer coefficients, temperature differences, and amount, type, and configuration of the heat transfer surface, and hence the heat flux on either side of the heat transfer device. So sinasabi dyan yung ating heat transfer coefficient. Siyempre, the higher heat coefficient meaning more efficient heat transfer. Sinabi din dyan yung temperature differences. The greater the temperature difference, the faster heat will transfer. Then the amount, type, and configuration of heat transfer surface. Siyempre kapag mas malaki ang ating surface area tapos yung materials pa na ginamit, siyempre may epekto ito sa rate ng heat transfer. So halimbawa na nga lang dyan is kapag naglagay tayo ng yellow sa isang basong tubig and then yung ice yung serve as a refrigerant and then i-absorb ng ice yung heat galing sa tubig. Hindi yung tubig yung serves as ating surrounding area. At ang gagawin ng ice, syempre, is palalamigin niya yung tubig. Kapag pinabayaan natin to at natunaw na yung yelo, parang ibabalik lang ng yelo yung init na na-absorb nga nung una. And yun lang sa component balancing refrigeration system.
So next is refrigerant system chemistry. System chemistry deals with any chemical reactions that could take place in an heat ventilation, air conditioning, and refrigeration system between the refrigerants, lubricants, and construction materials of various system components, such as compressor, heat transfer coils, connecting tubing, expansion device. Higher temperatures or contaminants such as air, moisture, or residual process chemicals like metal cutting fluids and cleaning agents complicate chemical interactions between components. Phase changes occur in the refrigeration cycle. In particular, the temperature extremes from the highest discharge line temperature to the lowest evaporating temperature are of importance to the end user. So basically, ang tinutukoy po sa slide na ito ay yung mga chemical reactions na nangyayari sa refrigeration system. And specifically, ang tinutukoy din po dito ay yung endothermic reactions sa mga refrigerants and various system components. At yun po ay nag-absorb po ng heat from the surroundings. Next slide po.
So, control of moisture and other contaminants in refrigerant systems. Moisture, water, is an important and universal contaminant in refrigeration systems. The amount of moisture in a refrigerant system must be kept low, an allowable maximum for satisfactory operation, efficiency, and longevity. Moisture must be removed from components during manufacture, assembly, and service to minimize the amount of moisture in the completed system. Any moisture that enters during installation or servicing should be removed promptly. So dito po, yung moisture daw po na nag-enter po sa ating refrigeration system during installation or service po, kailangan po siya matanggal kaagad-agad. Kasi po pag hindi po siya natanggal kaagad-agad, yung moisture na po na yun ay can then freeze into ice. Tapos po pag nag-freeze po siya sa ice, mabablock niya po yung capillary tubes natin and yung expansion devices po. Pag na-block niya po yun, madidistract po yung refrigerant flow. So, pag na-distract po yung refrigerant flow, obviously po, bababa po yung refrigeration system performance po natin. And yung moisture po, nagkakos po din siya ng undercharging and corrosion po sa ating system components.
Under pa rin po ng controls of moisture and other contaminants in refrigerant systems, dito po yung ating sources of moisture at effects of moisture. Sources of moisture. Moisture in a refrigerant system results from inadequate equipment drying in factories and service operations. During the manufacturing processes of refrigeration equipment or during service operations, insufficient drying of components can leave moisture trapped within the system. Nangyayari po ito due to improper procedures at yung hindi sapat na oras na nakalaan para sa drying or hindi sapat na equipment used for the drying process. Introduction during installation or service operations in the field. When refrigeration systems are installed or serviced in the field, there's a possibility of introducing moisture inadvertently. Nangyayari naman po ito sa improper handling of components, exposure to humid air during installation, o yung paggamit ng mga tools na hindi nalinis ng maayos or natuyo. Leaks resulting in entrance of moisture-laden air. Leaks in the refrigerant system can allow moisture-laden air to enter. This is particularly common in systems that are not properly maintained or have deteriorating seals and gaskets. Moisture from the surrounding environment can seep into the system through these leaks. Leakage of water-cooled heat exchangers. In systems that utilize water-cooled heat exchangers, leaks in the water circuits can introduce moisture in the refrigerant system. Nangyayari naman po ito dahil ng corrosion o yung mga poor maintenance ng water-cooled components. Oxidation of some hydrocarbon lubricants that produce moisture. Certain hydrocarbon lubricants used in refrigeration systems can undergo oxidation under certain conditions. This oxidation process can generate moisture as a byproduct, which then enters the refrigerant system. Wet lubricant, refrigerant, or desiccant. If lubricants, refrigerants, or desiccants used in the systems are contaminated with moisture, they can introduce moisture in the system. Nangyayari naman po ito during storage, pag-handle, or yung improper sealing of containers. Moisture entering a non-hermetic refrigerant system through hoses and seals. We called it non-hermetic if the package is made from polymeric materials or plastics. Non-hermetic refrigerant systems, which rely on hoses and seals to maintain integrity, are susceptible to moisture ingress if these components are not properly sealed or if they degrade over time. Moisture from the ambient environment can infiltrate through these openings. Yun po sa effects of moisture. Excess moisture in a refrigerating system can cause one or all of the following undesirable effects. Una po dyan ay yung ice formation in expansion valves, capillary tubes, or evaporators. Moisture can freeze within the system. Yun ang nagli-lead sa ating ice formation sa ating mahalagang components gaya ng expansion valves, capillary tubes, and evaporators. Yung ice formation po ito, gaya nga po na nasabi kanina, ay maaaring mag-obstruct ng flow of refrigerant, disrupt the operating of these components, at higit sa lahat yung mapababa yung system efficiency. Next is the corrosion of metals. Moisture ay nagre-react sa metal surfaces within the refrigeration system, leading to corrosion. Yung pong corrosion can weaken the structural integrity of components, compromise their functionality, and increase the risk of leaks. This can result in costly repairs and premature failure of the system. Copper plating. In the presence of excess moisture and certain contaminants such as acids, copper plating can occur. This phenomenon involves the deposition of copper onto metal surfaces within the system, which can further exacerbate corrosion and impair the performance of components. Chemical damage to motor insulation in hermetic compressors or other system materials. Moisture can degrade the insulation materials used in hermetic compressors and other system components na maaaring mag-lead sa electrical problems gaya ng short circuits at motor failure. Hydrolysis of lubricants and other materials. Moisture, gaya po sa metals, nagre-react din po yung ating moisture sa ating lubricants and other materials within the system na nagli-lead sa hydrolysis. This chemical reaction can degrade the quality and effectiveness of lubricants, reducing their ability to lubricate moving parts properly. Inadequate lubrication can result in increased friction and reduced efficiency of the system. Lastly, sludge formation. Moisture can combine with contaminants and degrade lubricants to form sludge or other deposits within the refrigeration system. These deposits can accumulate in critical components gaya ng compressor at heat exchangers na nag-obstruct sa flow paths, reducing heat transfer efficiency, at higit sa lahat yung damaging the overall performance of the system. Next.
Equipment and system dehydrating, charging, and testing. So ito pong dehydration, charging, and testing ay essential steps para ma-maintain natin yung efficiency at longevity ng ating refrigeration system, including yung kanyang component like compressors, evaporators, and condensing coils. First is the dehydration. Sa dehydration, it involves the removing of the moisture from the system para ma-prevent natin yung corrosion at impairment ng mga components. As ang dehydration, it is typically done using heat, vacuum, or dry air to eliminate moisture or any water vapor present. For heat, by applying heat to the system, the moisture evaporates and turns into a vapor. Then it can be removed from the system. It can be done by the heating elements inside the refrigeration system. Sa vacuum naman, it refers to the creating ng low temperature within the system. So pag yung pressure is na-reduce, yung moisture, it evaporates and then it can be easily removed from the system. And last naman is for dry air. Dry air can be also considered a low moisture content. It is used to absorb moisture from the system. Next naman is sa charging. Dito sa charging ay ito yung process ng pag-a-add ng correct amount of refrigerant to the refrigeration system. So we know naman na ang refrigerant, ito yung substance na nagpo-flow sa system. It absorbs heat and inside and then releasing it outside. Thus, nangyayari yung cooling process sa ating system. Itong charging is important kasi for example sa mga sasakyan, kailangan natin ng right amount of fuel para mag-work ito properly. Same goes naman sa refrigerant. Kailangan natin ng correct amount para mag-work properly kasi if for example hindi enough ang refrigerant, hindi mag-cool effectively yung system, and if too much naman siya is it can damage the system. Lastly is the testing. Ito sa testing, it checks the system if it has leaks. It checks the pressure levels and temperature control. Ito sa system is bina-verify lang na if ang mga components ay nag-function properly at ang system ay nag-operate as intended. Next slide.
Refrigerant containment, recovery, recycling, and reclamation. Containment during installation, service, maintenance, and decommissioning of refrigeration systems. The potential environmental effect of chlorofluorocarbon or CFC and hydrochlorofluorocarbon or HCFC refrigerants on ozone depletion and of those and the hydrofluorocarbon HFC and hydrofluorolefin HFO refrigerants on global warming make it imperative that refrigerants are confined to closed systems and recovered during service and at the end of life. Containment must be considered in all phases of a system's life, including first is design and construction of leak light and easily service systems. Refrigeration systems should be designed and constructed to be leak light and easily serviced. This means using materials and components that minimize the risk of leaks and allows for efficient detection and repair if leaks do occur. Second is leak detection and repair. Regular inspections and maintenance should be conducted to detect and repair any leaks promptly. This helps prevent the release of refrigerants into the atmosphere and ensures the continued efficiency and performance of the system. Third is recovery during service. When servicing refrigeration systems, such as during repairs or maintenance, it is important to recover any refrigerant that needs to be removed from the system. This recovered refrigerant can then be properly handled and recycled or reclaimed for reuse, minimizing the need for new refrigerant production. And lastly, recovery at system disposal. At the end of the system's life, during decommissioning or disposal, all remaining refrigerant should be recovered and properly handled. This prevents the release of refrigerants into the environment and ensures that they are either recycled or reclaimed for reuse or safely destroyed to prevent their harmful effects. Next slide po.
Next naman po is number 3, components and equipment. 3.1, installation systems for refrigerant piping. 3.2, refrigerant control devices. 3.3, lubricants in refrigerant systems. 3.4, secondary coolants in refrigeration systems. 3.5, forced circulation air coolers. 3.6, retail food storage refrigeration and equipment. 3.7, food service and general commercial refrigeration equipment. 3.8, household refrigerators and freezers. And 3.9, absorption equipment. So, itong mga components and equipment is madidiscuss siya sa mga susunod na slides. So, sa ngayon, unahin muna natin is yung sa insulation systems for refrigerant piping. Next slide po. Insulation systems for refrigerant piping. So, para yung efficiency ng insulation system na ginagamit natin sa mga refrigerant piping ay nakadepende sa iba't ibang factors. Una na nga is yung correct refrigeration system design. Dapat yung design ng refrigeration system
ay mag-a-account din sa heat load ng piping system at sa desired operating temperature ng refrigerant. So kapag hindi kasi siya nakadesign based sa mga factors na yon, pwede siyang mag-lead sa excessive heat gain and energy losses. Next naman is correct specification of insulation system, correct specification of insulation thickness. So, dapat dito naman, yung type and thickness ng insulation materials natin ay pinipili natin ng mabuti and based din sa iba't ibang factors. So, una na nga is yung andun din yung operating temperature ng yung refrigerant, tapos yung ambient temperature and desired energy efficiency. So, nakabase sa mga ganong factors yung pagpili natin ng type and thickness ng insulation materials. Next naman is correct installation of insulation and related materials such as vapor retarders, quality and continuity of vapor retarding system, installation quality. So, sa insulation, yung insulation, dapat naka-installed siya in a tight fit para ma-prevent natin yung air gaps. Kasi kapag yung mga air gaps na yon, sila ay pwedeng mag-result sa reduced efficiency ng system. So, sorry po. Yung vapor retarders ay tinatawag din na vapor absorber. So, yung vapor absorber is nire-regulate niya yung vapor na pumapasok sa system. And yun din, tumutulong siya para ma-prevent yung pagpasok ng moisture sa mga insulation. Kasi kapag nakapasok yung moisture sa mga insulation natin, pwede siyang mag-cause ng mold growth at corrosion. Next naman is adequate maintenance of the insulating system. So dapat magkakaroon tayo ng regular na inspection sa insulating system para malaman natin kung ano yung mga damage and repair na kailangan. Since sila nga ay pwedeng magkaroon ng corrosion and doon nga yung nagpapababa ng efficiency ng system. So, kailangan natin ng regular na maintenance. Next naman is refrigerant piping. So, refrigerant piping includes lines that run at cold temperature, that cycle between hot and cold, and even some that run at temperatures above ambient. These pipes use various insulation materials and systems and are insulated for the following reasons: energy conservation, economics to minimize annualized cost of ownership and operation, external surface condensation control, prevention of gas condensation inside the pipe, process control, for freeze protection and to limit temperature change of process fluids, personnel protection, fire protection, and sound and vibration control. Next slide po. So, itong picture, pinapakita niya is yung refrigeration process. So, this can be classified too as the vapor compression refrigeration system due to its main components, the compressor, condenser, metering device, and evaporator. So, yung process, nag-i-start siya sa compressor. Andun yung nagkakaroon ng work input sa compressor. So, yung refrigerant ay kino-compress in a compression chamber. And then, lalabas na siya sa compressor ng high pressure. And kapag high yung pressure natin, high din yung temperature. So, siya na ay high pressure, high temperature vapor. Tapos, yung high pressure, high temperature vapor na yon, papasok siya sa mga tube na nasa condenser. So, yung mga tube na yon ay napapalibutan siya ng cooler medium na pwedeng air or water. And yung vapor natin, tsaka yung cooler medium, nagkakaroon sa kanila ng heat transfer, transforming the vapor into liquid and releasing heat to the surroundings. So, dito sa condenser, nandito din nangyayari yung heat rejection natin. So, yung heat na nare-reject dito is tinatawag nating latent heat. Walang change in temperature, pero may change in phase. So, yung kaninang pumasok sa condenser na high pressure, high temperature vapor, lalabas siya ng condenser ng high pressure, high temperature pa rin, pero liquid na. Next naman is metering device. So sa metering device, andyan yung halimbawa ay mga throttle valve, ganun. So kapag yung high pressure, high temperature liquid ay pumasok ng throttle, kasi yung throttle kasi para siyang nag-act siya as restriction. So kapag dumaan dyan yung liquid, nagkakaroon ng rapid drop in pressure. So, pag biglang baba ng pressure, yun din yung nagkakos para hindi ma-maintain yung original na state na pumasok sa throttle. So, kaya mapapansin natin na kapag yung pumasok sa throttle na high pressure, high temperature liquid, ay lalabas siya ngayong low pressure, low temperature, and mixture na nung vapor and liquid. Tapos yung ano na yon, yung mixture na yon, before siya pumasok sa evaporator, yung temperature nun is yun na yung pinakamababang temperature na pwede nating makuha and pwede siyang nasa negative na. And then, yung refrigerant na yon, papasok naman ngayon sa tube ng evaporator. And dito naman nagkakaroon ng heat addition. Kasi yung refrigerant naman, tumatanggap naman siya ng heat mula sa surroundings. Yung heat na yon ay mula sa mga heat load. Ano yung mga heat load? Yun yung mga meat na inilalagay natin sa mga ref, ganon. And, ayun, so nagkaroon siya ng heat addition. And yung heat addition na tinatawag doon is, heat na dinagdag natin doon is natawag pa rin nating latent heat pa din. So, wala ulit change in temperature, pero may change in phase. So, paglabas niya ng evaporator, ano na siya, low pressure, low temperature, and vapor na siya. And then, papasok ulit siya sa compressor, magkakaroon ulit ng work input, lalabas ulit siya sa compressor ng high pressure, high temperature, hanggang sa umikot lang ulit yung cycle para ma-maintain yung refrigerating effect or yung desired operating temperature natin ng refrigeration system. Thank you po.
And so for the refrigerant control devices, this can be divided into 5 groups, which is the control switches, control sensors, control valves, regulating and throttling valves, and the relief devices. But first, we'll be starting with 2 control switches. So for the control switches in refrigerant and control devices remain vital for regulating and managing the refrigeration process that involves the temperature and pressure readings, energy efficiency, system prevention, and system diagnostics, ensuring that it runs efficiently and safely in the operation. And next is the pressure switches. Obviously, pressure switches are critically components in refrigerant control devices, operating with control switches to assure that refrigeration system operation and maintenance facilitates the pressure levels, bolster energy efficiency, incorporates reliable readings, and optimal conditions which would deliberately aid to assess the system diagnostics. And followed by the temperature switches. Temperature switches or thermostats are necessary for precise temperature control, energy economy, user comfort, and overall system stability in refrigeration applications. Thus, when thermostats are combined with control switches, they provide a comprehensive control system that indicates the refrigeration system runs effectively while also providing a controlled environment. Followed by the differential switches. Differential switches in refrigerant control devices play a key role in controlling and directing the operation of certain components, providing a mechanism to respond to changes in condition. It also aligns relatively with pressure performance, to which the pressure readings are carefully observed so that it would not exceed to its indicated limit. Thus, it is to further prevent major faults in optimizing the system. And followed by the float switches. Float switches in refrigerant control devices provides an imperative process in maintaining liquid levels in the system. Its function is to detect the rise level or volume to prevent the potential overflow and ensure that the flow of refrigerant is at ease. Thus, sensors and alerts are built in conjunction with the said switches to strictly examine and provide heads up among the operators when major issues and system failures occur. And next naman po is ang control sensors. So control sensors in the system, control sensor facilitate the integral framework integrated within the refrigeration, for they are designed to monitor various parameters and provide necessary data and feedback to the control switches. It also remains fundamental in the operation, specifically in assessing the precise control, as this helps to optimize the efficiency and performance of the refrigeration. And next naman po ay ang pressure transducers. So for pressure transducers, this mainly provides accurate information with regard to the pressure levels as it measures pressure changes and transfers the said data directly into control switches and signals. And this also likely reduces the possible errors and faults within the suction and discharge pressures, and is also able to adjust certain components to prevent extreme pressure conditions. And next naman po ay ang thermistors. Thermistors. The temperature of various parts of the refrigeration system is measured by thermoresistors, which are temperature-sensitive resistors. And the ability to manage the temperature is one way that thermistors enhance the efficiency of the refrigeration system. And based on the temperature input from the thermistors, the control system can adjust how parts like the compressor or expansion valve operate. And next naman po ay ang resistance temperature detectors. So compared to certain other temperature sensors, these resistant temperature detectors provide highly precise and stable temperature readings. Thus, reliable and consistent readings are made possible by their resistance temperature relationship, which is predictable and accurate. And followed by the thermocouples. Thermocouples are crucial for accurate and versatile temperature measurement, which allows the refrigeration systems to be controlled efficiently. And the fact that thermocouples can function in an extensive temperature range is also one of the advantages that they can provide. And because of this, they can be used in a variety of refrigeration system applications, ranging from extremely low temperatures in the evaporator to much higher temperatures in the condenser. And lastly, for the control sensor naman po is the liquid level sensors. So liquid level sensors aid in the control of condensate levels in refrigeration and air conditioning systems. They also prevent conditions that could lead to reduced system efficiency, such as inefficient heat exchange or compressor damage. Thus, in order to prevent water buildup or water accumulation that might affect the system performance and efficiency, they make sure that they condensate the removal systems that are switched on when necessary. And next naman po ay ang control valves. So for the control valves naman po in the refrigerant control devices, they also serve as a vital function for managing temperature and pressure, maximizing system performance, and controlling refrigerant flow. And in order to keep track of the amount of refrigerant that can pass through, they modulate the valves opening and closing. So under this po ay ang thermostatic expansion valves. So in this section, thermostatic expansion valves serve as a crucial part of the control valves that facilitate and control the flow of refrigerant to the evaporator. And its main function is to regulate the refrigerant flow of the superheat level in the evaporator. Thus, it is carefully maintained by the said component to further enhance the system efficiency and employ effective cooling. And next naman po ay ang electric expansion valves. This component po is somewhat similar to the performance of the thermostatic expansion valves, as they both function as a modifier and regulator in superheat control. And at some point, they might be differ depending on its usage, such as the controlling the valve opening using an electronic actuator, which provides a more efficient and responsive control. And next naman po ay ang regulating and throttling valves. So in this section naman po, the function of regulating and throttling valve is to manage the flow of refrigerant through various system components, and by regulating the rate at which the refrigerant reaches certain system components, these valves maximize the efficiency components certain system components, maximize efficiency, and sustain the proper levels of pressure and temperature. And under this section naman po is the evaporator pressure regulating valves. So this valve modulates the flow of the refrigerant leaving the evaporator, and also is primarily controlled to maintain the pressure in the evaporator of our refrigeration system. This also modifies its opening to regulate the flow of refrigerant when the pressure at the evaporator outlet varies from the intended set point. Thus, this modulation helps maintain ideal pressure conditions to ensure that the evaporator performs effectively. And next naman po is the constant pressure expansion valves. These valves are used to manage and regulate the flow of refrigerant into the evaporator coil while keeping the evaporator's pressure approximately constant. And this valve modifies the opening to maintain the constant pressure inside the evaporator and in response to variations in the load and temperature of the refrigeration system. And in addition to this is that these valves are made up to function effectively as cooling systems and adjust the shifting conditions. And next naman po is the suction pressure regulating valves. These are ideally utilized in refrigerating systems to assess and control the suction pressure compression inlet. And by ensuring that the compressor receives the refrigerant at the correct pressure, these valves help to maximize its efficiency and prevent potential risk in the operation. And lastly po ay ang condenser pressure regulating valves or kaya naman ay CPRV. These condensers are used in refrigeration systems to regulate and sustain the condenser's pressures by ensuring that the condenser runs within a certain pressure range. And these valves maximize heat rejection and system efficiency, wherein its function is to modulate the flow of refrigerant through the condenser coils. And through this process po, it aids to preserve a stable and optimal condenser pressure, providing a more efficient heat transfer and cooling.
Okay, hello. I think it's already time. So thank you for those students na unang nakapag-share ng info for each of the slide. After this slide. So, request ko, kailan kaya natin, kasi bukas, i-ask ko sana sa inyo na ituloy muna, magawa ng problem set, dun sa 1.5 hour natin. And then, weekdays, hingi ako ng time para maituloy natin yung discussion natin for this one, para hindi na to lalagpas ng next week. Anong time kayo available ng weekdays 5 to 8? Any day ng weekdays na 5 to 8. So, 1.5 hour lang naman yun. So, at least ngayon ay makapag-usap na tayo. Wednesday kaya. Wednesday 5 to 6:30. Or Wednesday 4 to 5:30. Available.
Online pa rin po ba po yung reporting po?
Online. Online yun. Online. Para maituloy natin. Lahat ba is available? Hello?
Ma'am, okay lang pong kaya, i-update na lang po namin sa GC po. Pag-uusapan lang po ng buong block po kung okay lang po sa lahat.
Okay, sige. Pwede kayong mamili ng time ng Wednesday.
Sige po.
Or any day. Okay, basta. Pero I prefer Wednesday or Tuesday. Tuesday or Wednesday. Pero kung talagang hindi kayo available ng time na yon, di yun. I-ano na lang natin. So, make sure that all of the students na etong kasunod na to ay ready for that day. And then tomorrow, what you will do is to submit, solve yung 3 problems and then submit it before time natin. Clear ba tayo doon? So it will
Noted
be
po.
submitted doon sa Google Classroom before end ng time natin. Okay? And then yun nga, yung continuation nito will be during weekdays na.
Noted po.
Okay. So, thank you for those student na nag-share ng info for each of the slide. So, nagkaroon ng clear na discussion. So at least, dahil isa lang yung nag-present, so marami siyang idea na i-share doon sa class at isa lang din yung pag-aaralan. So, ganun pa din doon sa mga susunod na slide na didiscuss natin this week. Naging maayos ba yung ganitong setup?
Okay lang po siguro, ma'am po.
Okay. So, yun. Goodbye, class. And see you this weekdays kung kailan yung mapapag-usapan niya.
Thank you po, ma'am.
Janela,
Thank you po.
Thank you.